Welcome to Tech Orbit. Enjoy this super video and don't forget to subscribe so you don't miss the next ones.
NASA allocated $29,41,39,455 to SpaceX in 2021 to build the prototype of the Starship lunar lander. However, in the last 2 years, specific updates on the progress of this module. Lunar landings have been rare despite NASA's goal of returning astronauts to the moon by 2026. However, there has been an avalanche of new images and updates on SpaceX's HLS spacecraft, and NASA has revealed significant advances in today's episode of Alphatech. We delve into these developments SpaceX together with NASA. Astronauts carried out a test of the SpaceX elevator intended for Artemis moon lander. The Starship plays a vital role in NASA's program as one of 2 crewed lunar landing modules commercial. Despite SpaceX's demanding schedule focused on initial test launches are actively reassuring the parties interested in their ability to undertake more complex missions in the future. NASA astronauts Nicole Mann and DG Wills Willick played integral roles in a recent comprehensive evaluation of a scale elevator model designed for the Starship human landing system SpaceX. This crucial system has a dual purpose, transporting astronauts from the Orion spacecraft in lunar orbit to the surface of the moon, and function as a habitat during its stay of approximately 1 week, and also facilitates its smooth return from the lunar surface to the ship. Orion spacecraft guaranteeing the operational success of the mission. The fundamental function of the elevator involves the efficient transportation of both equipment vital as well as crew members between the Starship's habitable segment, located near its apex, and the lunar terrain, allowing its lunar walks and essential operations on the surface. During this meticulous test, the astronauts lived an immersive experience with a prototype which faithfully emulated the operational design of the elevator system. This practical meeting not only demonstrated the functionality of the hardware, but it also provided valuable insights from a crew-centric perspective, improving its designed and assembled development trajectory. Meticulously crafted at SpaceX's state-of-the-art facility in Hawthorne, California, this mock-up elevator features a large basket section, scale equipped with functional mechanical components and crew interfaces meticulously calibrated for rigorous testing. In particular, NASA astronauts donned spacesuits that replicate lunar conditions, ensuring a realistic simulation. During the demonstration as part of Artemis 3 evaluation, the crew will use advanced spacesuits developed by Axiom Space, ensuring compatibility and effectiveness with the elevator system. The appropriate crew actively participated and provided feedback. Comprehensive information on various aspects of elevator controls, including door latches, interface mechanisms for deploying lift ramps, entry and exit, optimizing cargo space and dynamic operations while moving along a vertical rail system. These substantial advances They not only underline SpaceX's strategic focus and technical capabilities, but also challenge any lingering uncertainty about its ability to deliver on the ambitious lunar landing deadline for 2030. However, amid these triumphs, legitimate concerns persist regarding the ICT and operational complexities associated with the imposing elevator design specifically designed for lunar missions, plus within the facility's SpaceX's Starbase. There has been an accelerated pace in the development of crucial components for the lunar lander since August 2023. One notable development has been the appearance of distinctive white-tipped cones that experts believe represent mock-ups of the HLS variant. Starship intended for meticulous testing. What sets them apart is their inclusion of life support components, which means rapid advances in critical testing protocols and a breakthrough in the development schedule. At the same time, the company is going through a phase of transformative modifications to the design of this monumental lunar lander with the aim of forging an optimal and adjusted product tailored precisely to the demands of the mission. Let's delve into the evolution of these design models. First, 3 important modifications are noted in the rocket configuration. If you're enjoying the video, don't forget to subscribe so you don't miss a video. The most important change is the deployment of solar panels from fences located on top of the rocket. During flight, these panels expand, mimicking the typical deployment method of most spacecraft. Once they land on the moon, they retract without problems aligning themselves to the scratch on the side of the lander. The second striking modification refers to the legs of landing, noticeably smaller and seemingly fixed in place compared to the original design, which suggested larger legs and potentially retractable. This revised approach suggests a possible weight reduction by eliminating the need to retract the legs into the body. Last, SpaceX has strategically relocated the boosters by placing them in multiple capsules around the lander. These boosters elevated. Landing pads are intended to minimize surface disturbance during the lunar landing by mitigating the risks of debris and large rocks being struck into the lunar surface. Near landing, in particular, SpaceX achieved important milestones by succeeding in a series of critical engine tests, Raptor a feat announced by NASA in September. These rigorous tests validated the engine's ability to start and operate under conditions of extreme cold encountered during extended space missions, a crucial distinction of the Artemis missions compared to those in low Earth orbit. These missions involve prolonged periods of inactivity in space, subjecting the hardware to substantially higher temperatures, lower than those found during shorter missions closer to Earth. These advances underscore the calculated and impeccably executed of SpaceX's ambitious efforts, surpassing even the most optimistic projections. At this time, there is someone that calls into question SpaceX's readiness to achieve moon landings before 2030. Some skepticism persists regarding capabilities and skills SpaceX techniques. These comprehensive advances are a testament to the resounding affirmative answer that dispels any persistent uncertainty about SpaceX's ability to accomplish these ambitious lunar missions. Some people reviewing the representations of the HLS Starship may still harbor reservations or lack significant confidence in their potential achievements. The most notable concern for much revolves around the height of the Starship elevator. Although SpaceX's proposal for the Starship lunar lander is undoubtedly unique, presents a considerable challenge due to its enormous size and weight, the enormous 50M stack of spacecraft separated with the crew cabin. This staircase would require NASA astronauts to navigate a multi-story staircase when traveling to and from the lunar surface. It is significantly higher than that used in the Apollo program, about which NASA already had reservations about navigating such a staircase. High in the cumbersome and imprecise extravehicular activity, EVA lunar spacesuit would be extremely challenging and relatively risky. This isn't really a great design for a lander, and that's because Starship was never actually intended to be a lander-Starship landing. Vehicle is primarily an orbital vehicle, the upper stage of the entire launch stack atop a Super Heavy booster, and was designed primarily for that function. So it looks like, well, a rocket. This says a lot about the flexibility of Starship, to the extent that it can even be adjusted to suit this specific purpose in Team Defense National. It's safe to say that demonstrated reliability would be an absolute necessity for NASA to ever accept that solution. Of course, SpaceX could include a manual backup system and a ladder on the outside of Starship in the event of a complete system failure. But both backups would still present similar or greater risks than the national team ladder. However, the fact that SpaceX has tested a prototype Starship moon elevator makes it difficult for me to believe that the company will not ultimately produce a safe and reliable elevator by 2026, when Artemis 3 begins. In fact, SpaceX is totally able to achieve this just by taking a comprehensive look at everything SpaceX has accomplished in what is considered a relatively short period in the automotive manufacturing industry. SpaceX rockets have produced no less than 30 Starship prototypes and have conducted numerous wet general tests and static fires, along with flights of high-altitude testing and comprehensive orbital testing. Now, the Starship moon elevator is just part of the list of these achievements of low-cost manufacturing. Testing and repair activities do not appear to present any challenge to SpaceX. That's why NASA made the right decision for the Human Landing System program by opting for the lunar variant of Starship. And maybe not even SpaceX itself fully realizes the extent to which Starship will revolutionize activities on the lunar surface in the coming years. Lunar variant of Starship promises to advance the goals of the NASA based on the milestones established since 1972. The HLS variant of the Starship is not only a blessing to improve human exploration capabilities on the moon, It is presented as a door of entry to unlock potential avenues for space industrialization specifically designed to transport substantial payloads to the lunar surface. Affordably, SpaceX's formidable Meg rocket has the ability to transport large-scale mining and construction equipment intact. This cargo, weighing between 40 and 60 tons on Earth, constitutes a fundamental component to establish a fundamental lunar infrastructure essential for economic development and trade. The importance of equipment cannot be underestimated. Within this size, range constitutes the backbone to lay the necessary foundation to foster economic growth on the Moon and cultivate its commercial potential, which is even more fundamental for the lunar breakthrough. Is that diversified Starship variants will facilitate the establishment of construction facilities by accelerating the expansion of an economy in this natural satellite with abundant resources.
That's it for today's video. Don't forget to subscribe, like, comment and activate the notification bell so you don't miss any videos. See you soon.